Hello students and welcome to the quick solution of All India Cast Test Series JEE Advanced 2020 Test 1A Paper 2 Code GNH Physics. Let's move to question number 1. In question number 1, a hinge construction consists of 3 rhombus with the ratio of sides 3:2:1. Vertex A3 moves in the horizontal direction with velocity 12 meter per second. If angle at any instant is theta and velocity of A2 is v1 and velocity of vertex b1 is v2, then we have to check the validity of these statements. So if I assume the length of this side is L, then the length of this side is 2L and the length of this side is 3L. Then I can say that if suppose at that moment, if x is the separation of A3 from O, then I can write x as x is equal to 12L cos theta, because this separation becomes 6L cos theta, this separation becomes 4L cos theta, and this separation becomes 2L cos theta. So x is equal to 12L cos theta. So if I differentiate this equation, dx by dt is the velocity of vertex A3 that is given in the question 12, and this is equal to 12 into L into differentiation of cos theta is sin theta into minus of d theta by dt. So if I find the value of L into sin theta d theta by dt, then it comes out to be 1. Now in the given option A, it is given that when theta is equal to 45 degree, the value of v1 is 10 meter per second. So v1 represents the velocity of the vertex A2. So suppose this separation is y, then I can say that this y is equal to 10L cos theta. So if I differentiate this, dy by dt represents the velocity of vertex A2, that is v1, and it is equal to 10 into L sin theta into minus d theta by dt. So we know that the value of L into sin theta into minus d theta by dt is 1. So I can say that this is equal to 10 into 1. So 10 meter per second is the velocity v1. So option A is correct. Now let's check option B. Modulus of v1 is independent of theta. Since we have seen this quantity is a constant number, so it is independent of theta. So option B is also correct. Let's check the validity of option C and D. In option C, it is given that for theta is equal to 30 degree, v2 is equal to 6 meter per second. So let's analyze the situation. If v2 is the velocity of vertex b1, then I can say that minus d theta by dt, that is omega, is equal to v2, that is the perpendicular velocity, divided by length, that is 3L. So from here we can say that v2 comes out to be 3 into L into minus d theta by dt, and the value of L into minus d theta by dt is 1 upon sin theta. So that is equal to 3 into 1 by sin theta, and we have to calculate the value of sin theta at theta equal to 30 degree. So at theta equal to 30 degree, it comes out to be 1 by 2. So it comes out to be 6 meter per second. So option C is correct and option D is wrong. So the correct answer for question number 1 are option A, B and C. Let's move to question number 2. In question number 2, a projectile of mass m is projected from ground with initial speed v0 at an angle of 37 degree with the horizontal. In addition to gravitational force, a variable force F vector is equal to mg minus v cap also acts on projectile, where v vector is instantaneous velocity of the particle. Then we have to check the validity of given statements. So first of all, let's analyze the situation. At t equal to 0, suppose the particle is at this position and it is projected with a speed v0 at an angle of 37 degree. So at this moment, if I draw the free body diagram, mg is acting in this direction and a variable force is acting mg minus v cap. So at t equal to 0, the direction of velocity is this. So force is acting in this direction and its magnitude is mg. Suppose the particle is moving in some this way and this is the let path of the particle. So at some time t, the particle reaches to this position and let at that moment it makes an angle theta with the horizontal. Let the velocity of the particle is v at this moment. So I can say that if I draw the free body diagram again, then mg is acting in this direction and mg is acting in this direction, opposite to the velocity. So if I find out the value of tangential acceleration and the acceleration in vertical direction, I am considering this my x-axis and this my y-axis. So if I find out the tangential acceleration at, so the tangential acceleration at would be equal to g plus g sine theta into minus v cap. So suppose this angle is theta, then this angle is also theta. So the component of g in this direction is g cos theta and in this direction is g sine theta. So this is the value of the tangential acceleration at that moment t. At the same moment, if I find out the acceleration in vertical direction, then I will see that if this angle is theta, then this angle is also theta and the component of g in this direction is g cos theta and in vertical direction is g sine theta. So again it is g plus g sine theta into minus j cap. So I can say that the magnitude of tangential acceleration and the magnitude of vertical acceleration is same at the every moment of the path of the particle. So I can say that at is equal to ay, or for the same time interval I can also say that delta v in tangential direction is equal to delta v in vertical direction. So if I substitute the value delta v in tangential direction, so at this moment the velocity is v, so v minus v naught is equal to delta v in vertical direction. So in vertical direction, if I take the component of this velocity, here it will be v sine theta, and at t equal to 0 it will be v naught sine 37 degree. Now let's check the options. In option A, it is given that at topmost point net force acting on the projectile is root 2 mg. So at the moment when the particle reaches to the topmost position, let this is the topmost position, then at this moment mg is acting in this direction, the velocity is in this direction v dash. So at that moment the variable force mg will act in this direction. So the resultant of these two forces will be root 2 mg. So option A is correct. Let's check option B. At topmost point, velocity of projectile is 2 v naught upon 5. So at topmost point, the value of theta becomes equal to 0. So at topmost point, when theta equal to 0, let's check what is the equation will become. V minus v naught is equal to 0 minus v naught into sine 37 degree, that is 3 by 5. So on solving this, the value of v comes out to be 2 v naught upon 5. So option B is correct and option C is wrong. Let's check option D. Radius of curvature of trajectory at topmost point is 4 v naught square upon 25 g. So at topmost position, the radius of curvature can be given as v square, that is the velocity at this moment, that is 2 v naught upon 5 whole square, divided by the component of acceleration perpendicular to this velocity at the topmost position, and the perpendicular component of acceleration is g. So on solving, it comes out to be 4 v naught square divided by 25 g. So option D is also correct. So the correct answer for question number 2 are option A, B and D. Let's move to question number 3. In question number 3, in the system shown in figure, a cylinder is pressed between two wedges as shown. If velocity of wedge 1 is 10 meter per second towards left, velocity of wedge 2 is V2 and velocity of cylinder is V3, then choose the correct options. So it is given in the question. This is moving in this direction with a velocity of 10 meter per second, and it is moving in this direction with a velocity V2. Then the velocity of 3 is in this direction as well as in this direction. So I can write the velocity V3 vector as Vx minus I cap plus Vy into j cap. I am assuming that the surfaces in contact are smooth. So if the contact between the wedge 1 and the cylinder is intact, then the relative velocity of cylinder with respect to wedge, then the perpendicular component of the relative velocity of cylinder with respect to wedge 1 is always 0. So from this, I can say that the value of Vx must be equal to 10 meter per second. So now, if I check wedge 2 and the cylinder, suppose this is wedge 2 and this angle is 37 degree and it is moving in this direction with velocity V2, then this is the perpendicular line. Then the same concept I will apply again, that the relative velocity of the wedge 2 with respect to cylinder in perpendicular direction must be 0. So suppose the velocity Vx is in this direction and Vy is in this direction of cylinder. If this angle is 37 degree, then I can say that this angle is also 37 degree and this angle is equal to 53 degree. So if this angle is 37 degree, then this angle is also 37 degree and this angle is equal to 53 degree. So the component of V2 in this direction is V2 sine 37 degree, and that must be equal to the component of Vx in this direction is Vx cos 53 degree, and the component of Vy in this direction is Vy cos 37 degree, that is minus Vy cos 37 degree. So if I substitute the data, V2 into sine 37 degree, that is 3 by 5, is equal to Vx, that is 10, into cos 53 degree, that is 3 by 5, minus Vy into cos 37 degree, that is 4 by 5. So on solving, it comes out to be 3V2 is equal to 30 minus 4Vy. So if I check option A, if V2 vector is equal to minus 10 I cap, it means that the value of V2 is 10. So if I check these statements for option A, if V2 is equal to minus 10 I cap, it means the value of V2 is 10. So if I substitute the value of V2 as 10, then this will become 30 is equal to 30 minus 4Vy. So the value of Vy is equal to 0. And at that moment, if Vy is equal to 0, then V3 magnitude is equal to Vx, and that is equal to 10 meter per second. So option A is correct. Let's check option B. If V2 vector is equal to minus 20 I cap, if it is equal to minus 20 I cap, it means V2 is equal to 20. Then this will give me 60 is equal to 30 minus 4 Vy. And from here, the value of Vy comes out to be 15 by 2. So if I find out the velocity V3 at this moment, that is equal to under root 10 square plus 15 by 2 whole square. So if I solve this, it comes out to be 25 by 2 meter per second. So option B is also correct. Let's check option C. If V2 is equal to minus 10 I cap, then modulus of V3 is 25 by 2 meter per second. That is wrong. In option D, if V2 is equal to 20 I cap, so if V2 is moving in this direction, then in this equation, the value of V2 will become negative. That will be minus 60, and 4 Vy is equal to 90, and Vy is equal to 45 by 2. So in this situation, if I find out the magnitude of V3, it is greater than 10 meter per second. So option D is wrong. So the correct answer for question number 3 are option A and B. Let's move to question number 4. In question number 4, a smooth ring A of mass m can slide on a fixed horizontal rod. A string tied to the ring passes over a fixed pulley and carries a block of mass 3m as shown. If system is released from rest and acceleration of ring and block are a1 and a2 respectively at the given instant, then we have to check the validity of these statements. So if I draw the free body diagram at this instant, suppose T is the tension in the string, then 3mg is acting in this direction, T is acting in this direction, T is acting in this direction. Let the acceleration at that moment a1 is of ring and a2 is of block. So if I write the equation, then T cos 37 degree is equal to mass into acceleration, that is m into a1, that is my first equation for the ring. If I write for the block, then 3mg minus T is equal to 3m into a2, that is my equation 2 for the block. So if I write the constraint equation, then acceleration a1 is in this direction. If I take the component of a1 in this direction, then it would be a1 cos 37 degree, that is 4 by 5, and this must be equal to a2. This is my equation 3. So from equation 3 we will get the option A. So option A is the correct answer. And if I solve this equation, equation 1, equation 2 and equation 3, then we will find that the value of a1 comes out to be 60g by 73 and the value of T comes out to be 75 by 73 mg. So option D is correct and option B is also correct. So the correct answer for question number 4 are option A, B and D. Let's move to question number 5. In question number 5, for the system shown in figure, all the surfaces are smooth, pulleys and strings are ideal. If system is released from rest, then. So if I draw the free body diagram at this instant, then 2mg is acting in this direction. Let the tension T1 is acting here. Suppose this block B is moving in this direction with acceleration a1. So it is also moving downward with acceleration a1. The tension T1 is acting in this direction and the tension T2 is acting in this direction. So if I write the equation for block C, then 2mg minus T1 is equal to 2m into a1, that is my first equation. If I write for the block B, then T1 minus T2, that is the net force in forward direction, and this is equal to mass, that is 2m into a1. So that is my equation 2. So if I apply the equation of motion on block A, then the tension in this string is T2 by 2 because the pulley is massless. So I can say that T2 by 2 is equal to mass, that is m, into its acceleration. Let its acceleration is a0. So m into a0. This is my equation 3. Now I have to write the constraint equation because there are 4 variables and these are 3 equations. So I can apply the constraint equation on this string. If the length of this string is L1 and the length of this part is L2, then I can say that summation of L1 plus L2 is equal to constant because the length of string remains constant. If I take double derivative of this equation, then we will get the relation in acceleration. So L1 double dot represents the acceleration of this point with respect to this point. So that is A1 plus double dot of L2 gives the acceleration of this point with respect to this point. So that will be A1 minus A0 and this is equal to 0. So from here we will get 2A1 is equal to A0. So this is my fourth equation. So if I solve this, then the value of A1 comes out to be g by 4. That is the acceleration of pulley 1. That is the acceleration of pulley 1. And if I calculate the value of A0, the value of A0 from this equation comes out to be g by 2. So if I find out the acceleration of block A with respect to pulley 1 because the other pulley is non-movable. So if I calculate the acceleration of block A with respect to pulley 1, then I will find that it is equal to G by 4. So option A is correct and option D is also correct. So the correct answer for question number 5 are option A and D. Let's move to question number 6. In question number 6, two blocks A and B connected with a string of length L are placed on a rough horizontal plane. Coefficient of friction between A and surface is 0.5, that is half, whereas that between B and surface is 0. Block B is given velocity V0, that is equal to under root 2gl, perpendicular to the length of a string on horizontal surface. If T is tension in a string and A0 is the acceleration of block A just after the velocity is imparted, then we have to check the validity of given statements. So let acceleration of block A in this direction is A0 and the velocity imparted perpendicular to the string at that moment is V0 in this direction. So if I write the equation for block A, then tension T is acting in this direction and friction is acting in this direction, and the friction has reaches to its maximum value, and this is equal to half into normal reaction, that is equal to 2 mg. So on solving, it comes out to be mg. So T minus mg is equal to 2m into A0, that is my first equation. And if I study the motion of block B from the frame of A, then I have to apply a pseudo force on this block B. So T is acting in this direction and the pseudo force m into A0 is acting in this direction, and with respect to block A, it is moving in this direction with a velocity V0 at that moment. So I can write T plus ma0, that is net force toward the center, and this is equal to m into V0 square by L, and the value of V0 square by L is equal to 2g, so it is equal to 2 mg. So if I substitute the value of ma0, that is T plus ma0 is T minus mg by 2, that is equal to 2 mg. So if I solve this equation for T, then the value of T comes out to be 5 by 3 mg, and if I solve for A0 further, then it will give me G by 3. So the correct answer for question number 6 are option A and D. Let's move to question number 7.